So here's a problem. So a travel agency specializing in Caribbean vacations models its daily revenue in dollars on day N of the year by this following function. So find the company's revenue on February 1st. So we can kind of already know that because you're gonna go on a vacation on the Caribbean, there's certain days where maybe it might be really really high, maybe it might be really really low. So it would kind of make sense for us to model it with maybe a cosine curve, and in a little bit you're gonna know actually what a cosine curve kind of looks like, and also the sine curve. So there's really nothing to this problem. All we really have to do is figure out the company's revenue on February 1st. We already know that n equals 32, so all we have to do is just plug everything in there. Now, one of the things to really notice is that notice here you have a 2 pi. This immediately tells me that this might be in radians. Okay, so make sure that your calculator is on radians. Okay, so all we have to do is just plug in 32. So r of 32 is going to be equal to 600 plus 500 cosine of 2 pi times 32 divided by 365. So go ahead and put that all into your calculator, and what you're going to get is about 1026.04. Okay, so that's what you end up getting if you do this problem. So there really was nothing to this. All you had to do was just plug it in. But I think one of the things that you have to be very careful with is being able to convert it from radians to degrees when necessary, and also be able to put this in the calculator. So what exactly does this cosine curve really look like? So I think that's kind of like the main thing. So we're gonna have to start graphing a couple of these things. So let me just go to the next page. So I'm gonna just say graphing sine and cosine curves. Okay. So we're going to go ahead and do this. So what we really want to figure out is what exactly does y equals sine theta look like, or sine of x, and what does y equals cosine theta look like. Okay. Now what I did is I'm uploading a little unit circle up on Canvas, so you can go ahead and take a look at the unit circle, and if not, then you can just go back to the I forgot what it was. They were right here. So this unit circle, I'm going to be mainly using this to kind of graph these guys. So what I'm going to be doing is that I'm going to be plugging various angles to be able to figure out what the sine curve looks like. So I'm first going to start off with sine. So I'm going to start off here. I'm going to write it like this. Okay, so here's my theta values, my angles, and here's my y values. So obviously I should plug in 0 for theta. Okay, I should probably plug in this in. And usually when we deal with these, we always want to write them in radians. So 0 is basically where you want to start off with. Now afterwards, what would be the best ways to break this up? So if I go back to my unit circle, you'll see that a lot of these values are very, very weird. You have square root of 3 over 2, 1/2. These can be really hard to kind of graph. And remember that the sine curve is always our y value. So what I'm going to do is I'm going to look at the quadrantal angle. So for example, I'm looking at 0 degrees or 0 radians. Then the best nice number is going to be a pi over 2. Okay, so let me maybe write this in a different color. So this one will probably be the best one, okay, because you have 0, 1. Then after that will be pi, because this one looks a lot nicer too, and also 3 pi over 2, because this one's also really nice. Okay, and then finishing it up at 2 pi, which finishes up one whole cycle. So if I go back, what I'm going to do is I'm going to break this up into the angles pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so when you have theta equals 0 radians, your y value is going to be 0, and that's just what you got to do. So you're looking at all the y values on the sine. When theta is pi over 2, my y value is going to be equal to 1. And you can see that because if you go back to the unit circle, when theta is pi over 2, my y value is going to be equal to 1. Then when it's pi, it's going to be 0. Okay. When it's pi, so it's going to be pi over 2, it's 1. Then when it's pi, it's going to be 0. When it's 3 pi over 2, it's going to be negative 1, which is going to be here. And then when it's 2 pi, it's going to go back to 0. And notice that there's not going to be straight lines because you can see that this is not linear at all. It's kind of more curvy. So it looks more like this. Oops. I already messed this up. Okay. So it kind of looks like this. Now notice that I can keep plugging in more angles and you'll see that this curve can actually continue on. So you actually will get some sort of wave here. Okay. So there's a couple things to kind of note. From here to here, how high this particular curve is from the middle is what we call the amplitude. Amplitude. Okay, and when it completes one full cycle, notice that it started at 0 and then it completed 1 before it continues repeating. It's what we call a period. Okay, so the period basically is how far you go from one end to another end to complete one full cycle. And you can see that it completes one full cycle at 2 pi. Here the amplitude is just 1 because it is just 1 unit up. Okay, so this is what the sine curve looks like. Okay, now what does the cosine curve look like? Well, the cosine curve is going to look something like this. Same thing. The best way to kind of do this is by having the same angles. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then when you look at the angles, notice that instead at 0, you're going to start at 1. And just look at the unit circle. At 0, you're going to do 1. So if you look here, 0 degrees, our cosine is our x value. It's just going to be 1. Okay, and then we're just going to continue. Okay, so pi over 2 is going to be 0. Pi is going to be negative 1. 3 pi over 2 is going to be 0 again, and then 2 pi is going to be 1. And notice that it completes one full cycle. So if I were to kind of draw it, it kind of looks like this. You can see that if I keep drawing more angles, you're going to get more waves. Okay, so same thing, the amplitude is going to be 1. Okay, so you can see that the amplitude here is going to be equal to 1. And then the period for it to complete one full cycle, so its period is going to be equal to 2 pi. Okay, so the cosine curve and the sine curve kind of look the same. All it is just like if you were to shift the sine curve just maybe pi over 2 units over, you're going to get the cosine curve. Okay, so it's just shifted up a little bit. So this is basically the graph and the graph of the sine and the cosine curve. Okay, now what we really want to do is we want to be able to graph these guys in different ways. So we want to be able to graph them the following way. So because not all the time are we going to have just sine theta and cosine theta. Okay, so in particular what we're really going to be looking at is modified versions of the sine and the cosine curves. So modified sine and cosine functions. Okay, and what the modified versions are going to look like is the following way. So basically, we're going to be looking at y equals a sine b t, and then y equals a cosine b t. So here what we have is that you have amplitude equals to a, and the period here is going to be equal to 2 pi divided by whatever this b is. So notice that we have something right in front of the cosine curve and the sine curve, which is a. So basically when I multiply it by a factor, it's just going to stretch it. Okay, well we've learned in college algebra before, it's going to stretch the curve, and then this b is going to shrink it or make it a little bit or make it more, I don't know how you say it, so shrink it or maybe making it a little bit, stretch it out in the x direction. So here, what we want to do is how is that going to affect the graph if I have a number right in front of it and a number in the inside. So basically a way to do it is that the amplitude is always going to be a, whatever that number is, and then the period is going to be either shrunken or extended to 2 pi over b. So let's do a couple of examples to really kind of take a look at this. So obviously, if you've taken a much more higher level trig class or another calculus class, these problems can be a lot more complicated, but we're just going to deal with these guys. So let's say, for example, we want to graph the following thing. So we want to graph y equals 2 sine of x. Okay, so how would you graph something like that? Well, notice here that there's a couple things I see. The amplitude is being multiplied by 2. So amplitude is equal to 2. It's not equal to 1 anymore. Has anything happened to the period? Nothing has happened to the period. It's still the same. X is still the same. Okay, so no change in period. So it's still going to be from 0 to 2 pi. So the only thing that's really going to change for the sine curve, which looks like this, is just going to be, it's going to be stretched up by 2. So instead of 1, this is now going to be a 2. So if I were to graph this, it'll look something like this. So nothing's going to change in the period. So this is still going to be the same, 0, pi over 2, pi, 3 pi over 2, 2 pi. This is still going to be the same, but the amplitude is now going to be different. Instead of 1 being 1, -1. Now, I'm sorry, that's wrong. Instead of being -1, 1, it's now going to be 2 and then -2. So this is now stretched. So at 0, it still stays at 0. So all of the amplitudes are, so everything's going to be stretched out. Okay, so notice that the shape is going to be exactly the same. It's just that now this graph is stretched out twice as long on the y direction. Okay, so that's what that looks like. Now, usually we only want 1 period. Obviously, you can keep drawing more, but 1 period is good enough. Okay, so if you have something that's being stretched, that's what it's going to look like. Okay, so let's do this problem. Okay, so graph. Let's say we want to do y equals 3 cosine of x. Okay. So again, here, there's going to be no changes in the periods, but instead, the amplitude is going to change. It's now going to be at 3. So the amplitude is going to be at 3. So when I graph it, nothing's happening in the period. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Nothing's changing there, but now the period is now, instead of 1, is going to go up to 3. Maybe make it a little bit bigger. Whoops. 1, 2, 3. So 1, 2, -3. Okay. So now the cosine, if you look at the cosine at 0 starts at 1. Now it's no longer going to be at 1. It's now going to be at 3. Okay. It's going to be at 3. Okay. Then everything else is going to stay the same. Okay. So everything in the 0 stays the same. That just nothing happens. It's just basically the big crest is what you're basically expanding. So at pi is going to be -3. Then 0, and then back to 3. Okay, so if I were to graph it, it looks something like this. So notice that the wave is now much more stretched out. Okay? All right, now let's do one last problem. Okay, so what would y equals -2 cosine of x look like? Okay, so when there's a negative in there. Well, first, let's start off by drawing the regular cosine curve. Okay, so that way you can kind of see. So y equals cosine of x. We know what y equals cosine of x looks like. Starts at 0, pi, pi over 2, pi, 3 pi over 2, 2 pi. Here's our x, so here's our y. And the regular cosine curve has an amplitude of 1. Okay, and it starts at 1. Okay, so it kind of looks like this. Okay, now this is not quite what we want. What we want instead is this, y equals 2 cosine of x. And then not only is it 2, it's negative. Okay, so notice what's going on here. So if you see here, there's a couple things that's going on. So let's start off with this 2. Okay, when I start off with this 2, what am I doing with the cosine? Well, this is being multiplied by a factor of 2. So my amplitude now is 2. So instead of being at 1, -1, now I'm going to be at 2. Okay, so let's go ahead and graph that. So at 2 is going to be here at 0. Everything's going to be the same. Pi over 2, pi, 3 pi over 2, and then 2 pi. Then at 2 pi over 2 is going to be 0. Pi is going to be -2. Then 3 pi over 2 is going to be 0, and then back at 2 pi. So this is what the graph kind of looks like. Now this would be true if it was +2, but now we have a negative. So if you remember the rules from pre-calc or college algebra, you know that the negative flips the entire curve. So basically, instead of this being a 2, it's now going to be down at a -2. Same thing with this guy. This guy is now going to go up. So basically, this is what the graph is going to look like. So if I wanted to graph y equals negative 2 cosine of x, all I have to do is do exactly the same thing. Whoops. Do exactly the same thing, but now it's going to be at negative 2. So I'm going to have pi over 2, pi, 3 pi over 2, 2 pi. Okay? So initially, it was at 2. Now it's going to be at negative 2. This is going to be down here at negative 2. This one's going to stay the same at 0, okay, because flipping that is not going to do anything. This negative 2 is going to be now a positive 2. This 0 is going to stay at 0, and this 1 is going to start at negative 2 now. So my graph kind of looks like this. So now it's basically flipped. So if you can see here, from here to here, I have flipped the graph. So it's now flipped. So now that's the only thing that you have to really worry about when you have a negative in there, because the amplitude gets stretched, but then you also have this negative that's going to switch it around. Okay, so in the next video, we're going to look at what happens when the period is changed.